And so again, like we said, when the value of K sub D is equal to the magnitude of the concentration of free ligand, then half of the receptor molecules will be occupied. Okay? When concentration of L equals KD, F is 1/2. And generally, this is what we're looking for. We don't have this information. We're trying to get this by changing this and measuring this. So again, your hyperbolic relationship is what you're looking for if you have one-to-one binding. Okay. So you can plot fractional saturation versus ligand concentration. And then to make this curve, we use binding assays, and I'm going to talk about probably only one. But experimental binding assays would be used to produce this curve, and so then once you make your curve, you can get your information off of it. I think I just answered this, but to produce this curve, which parameter do you have control over? Concentration of ligand. So I have some known amount of protein that I start with. I put some known measured amount of ligand into that solution, and I measure some outcome that is related to bound or unbound protein. Then I vary that concentration. I raise it, repeat. I raise it, repeat. And I'm slowly but surely plotting this for myself. So then the parameter that you're measuring is this saturation, and you can do that a couple different ways. So you might be measuring, just the protein concentration, just the bound concentration. You should be measuring some property about the protein that's changing. The example that we will look at is radioactivity. So if you tag your ligand with tritium or this hydrogen isotope, you can then capture radioactive output. Use the scintillation counter. We'll go through this. You'll see those measures of radioactivity, and as it increases and increases and increases, more and more radioactivity means more and more binding. The other way you could do this is, again, some sort of fluorescence microscopy, some sort of light transmittance, or light spec to get that. So again, this is the way it actually looks in your textbook, ligand concentration on the x-axis, and then the concentrations of the complex are here. And so where it's saturating is where it would be 1, and then half of that concentration would be F.5. So there's sort of an important assumption here. The number of protein receptors needs to be really small compared to the total ligand concentration. This is the critical parameter that we have control over. So the amount of ligand that gets bound is essentially the concentration of the complex. And if we let the amount that gets bound be much, much less than the total is free plus bound, but if this is really, really small, then we can just we can assume whatever we put in is the amount that's still free, okay? Because otherwise, once we put it in and some of it gets bound up, how do we decide what concentration is left over that's still free? This plot here is the concentration I put in and that I controlled. Okay. There's another slide about this later, and the other thing I will just say is that I will make it abundantly clear on homework and exam questions on whether or not you should be using this assumption.